It hits you sometimes, doesn't it? This feeling that the digital world is just relentlessly throwing information at us.
Oh, yeah.
For anyone trying to get a handle on things, it can feel like trying to drink from a fire hose.
It's a very real sensation. I mean, the speed at which the digital landscape changes is quite remarkable. And truly understanding the fundamentals, let alone the latest developments, can feel like, well, a constant uphill battle.
That's precisely why we're here. Welcome to the deep dive. Our aim is pretty straightforward. We sift through the mass of information out there. We've got a stack of sources in front of us, and we extract the core insights, the stuff that really gives you a solid understanding.
Kind of your shortcut to being well-informed.
Exactly. With maybe a few surprising details thrown in, just to keep things interesting.
And today we're plunging into something absolutely foundational to the web as we know it, HTML. We have this comprehensive document here that traces its history and evolution, right from the initial ideas to its modern-day applications.
Perfect. So for you listening, our mission today is to map out the journey of HTML. We want to pinpoint the crucial moments, grasp the forces that drove its evolution, and give you a clear picture of how it all came together without getting lost in, overly technical jargon.
Sounds good.
Okay, let's unpack this. Where did this language of the web actually originate?
Right. Well, it all begins with the basic principle of markup languages. You got to imagine it like adding annotations to a document that are separate from the content itself.
Okay, like little notes for the computer.
Exactly. These annotations act like instructions for a computer, a parser or interpreter, telling it how to structure and display that content. The groundwork for this was established way back in 1986 with an ISO standard, ISO 8879. Also known as SGML.
SGML, Standard Generalized Markup Language.
That's the one. This provided a formal grammar for defining these annotations, kind of like rules for writing,
So SGML was the foundation, the underlying grammar. How did we move from that to, well, the web pages we see every day?
Okay, so jump forward to CERN, the European Particle Physics Laboratory. They were using a specific annotation style based on SGML called SGML GUID.
Right.
And here's where it gets really interesting. A contractor there, Tim Berners-Lee, his email, in fact, was timble@info.cern.cg. He took SGML GUID and used it as the springboard for something revolutionary.
Okay.
He envisioned non-sequential writing text that links to other text, which we now know as hypertext.
The basic idea of links.
Yes, but he didn't stop there. He expanded it to include graphics, video, and sound, what we now call hypermedia.
Yeah.
And his annotation system for all of this, he called it HTML, Hypertext Markup Language.
Wow. It's almost hard to imagine the web starting with just that. I recall reading about Nikola Tesla's vision, like this global network of knowledge sharing. How did that grand idea compare with the initial way the World Wide Web was actually used?
That's a fascinating comparison. Tesla envisioned this vast interconnected sphere of information, right? But the initial use of the World Wide Web tended more towards being an electronic paper format.
Huh. More like just reading documents online.
Pretty much. People were accustomed to reading documents in a linear way. And that's largely how they first interacted with the web, which was, somewhat different from the more dynamic hypermedia vision Tim Berners-Lee had.
But the idea was there.
Oh, yeah. In fact, in its early days, HTML was described as a language for transmission of global hyperdocuments, really emphasizing that multimedia interconnected aspect from the very beginning.
So that core idea of interconnected, rich media was there from the start, even if it took some time for its full potential to be, realized. Now, you mentioned that early HTML started to move away from that SGML foundation. What caused that divergence in those early years?
Right. Well, because the very earliest versions of HTML lacked strict formal definitions for its annotations, its tags, it naturally began to drift away from the ISO 8879 standard. It was a bit loosey-goosey at first.
Okay, that makes sense. Sort of evolving organically.
Exactly. But there was a movement to bring it back into alignment. And on November 24th, 1995, HTML version 2 was released, with the explicit goal of being more closely related to ISO 8879, a bit more formal.
Trying to get everyone back on the same page. And this is where the World Wide Web Consortium, the W3C, comes into play, right?
Precisely. The W3C was established in October 1994 at MIT's Lab for Computer Science, with support from DARPA and the European Commission. They essentially took on the role of guiding the development of web standards.
The guardians of the web, kind of.
You could say that. They released version 3, codenamed Wilbur, in January 97, and a notable change there was the removal of the specific tags for adding mathematical formulas.
Interesting. Why remove math?
That's a good question. Probably complexity or lack of widespread use at the time. Then came version 4, or Cougar, in December 97. This was a significant attempt to fully conform to the SGML standard. And following that, there were several subversions of v4 released over the next few years, 4.01, etc., just refining and making small improvements.
So a period really focused on trying to align with those established international standards. But then things took a pretty different turn with HTML5, didn't they?
Oh yeah, very significant shift indeed. When version 5 was released officially, October 28, 2014, though it was in development for years, it marked a clear break from that ISO 8879, that SGML foundation.
How so?
Instead, HTML5 basically said, okay, we're defining our own specific meanings and rules for our annotations, our tags. This was a major turning point, prioritizing the practical needs of web development over strict adherence to a broader, older document standard.
More about what web developers actually needed day to day.
Exactly.
And one of the really talked about new features in HTML5 was the canvas element. What made that such a game changer?
Canvas. Yeah, that got a lot of hype. Think of it as just a blank frame, a rectangle, within your web page, where scripts, primarily JavaScript, can run to draw 2D graphics and even simulate 3D stuff.
So drawing directly in the browser.
Pretty much. Now, while adding dynamic elements to web pages wasn't entirely new before HTML5, this canvas element provided a standardized and really powerful way to interact with the user, their computer's hardware, and other software in a much more visual and interactive way. It really opened the door for web apps, games.
And less reliance on things like Flash, right?
Absolutely. Yeah. This played a big role in the eventual decline of those plugin-based technologies.
It sounds like that really opened up a new era for what you could do directly within a web browser. Now, HTML is built on elements, these fundamental building blocks. What are some of the most basic ones, and how have they changed or evolved over time, especially comparing, say, HTML4 to HTML5?
Right. There are tons of fundamental elements, and yes, some have seen significant changes, while others have kind of become obsolete as web development best practices evolve.
Like?
Let's take basic text formatting. We have things like P for paragraphs and H1 through H6 for different levels of headings. These have been around forever, basically. They have roots in early document structure.
Standard stuff.
Yeah. There was also HP1 for highlighting text in a multi-level way, but that's not really used now. And who remembers the typewriter tag? That was literally for displaying text in a monospaced typewriter-style font.
Huh. Yeah, I remember that one. Seems ancient now.
Totally. Comments, which are in the code the browser ignores, have always been done with.
Yeah.
And then there's the simple line break, BR. Still widely used, typically doesn't need a closing tag in HTML5.
Ah, the BR. A real workhorse of early web layouts, maybe sometimes overused.
You could say that. And what about links? The absolute core of how we navigate the web.
Crucial.
Absolutely. The anchor tag, A, is used to create hyperlinks. The href attribute specifies the destination, another web page, or maybe a specific section within the current page using that hash symbol, hashtag identifier.
Right.
You could also define a specific spot within a document that a link could point to using the name attribute, though bead is more common now. The typey attribute used to specify the kind of content at the link. For a full list of these, you check the IAEA media types resource. Then you have the target attribute, which controls where the linked page opens, like blank for a new tab or window or self-recurrent frame or window.
Standard behavior we expect now.
Exactly. Interestingly, there were also attributes like shape and chords that let you define clickable areas within an image, like an image map.
Oh, right. Image maps. Less common now, maybe.
Yeah, CSS and JavaScript handle a lot of that better now. More modern attributes include download to force the browser to download the linked file, media to specify for which type of device or screen the link is optimized, and rel to define the relationship between the current page and the linked page.
Rel is important, right, for SEO and accessibility.
Very important. Things like indicating an alternate version, the author, a bookmark, or using nofollow to tell search engines not to pass authority, or norfer for privacy. There's also prefix, prev, search, tag, lots of options there. And rev was used to define the reverse relationship of the link, though it's largely obsolete now.
Wow. It's remarkable how many options were built into even the early link tags. Okay, moving on to lists, another fundamental way to structure information.
Yep, lists come in various forms. List and XMP were earlier ways to present text with fixed spacing, kind of pre-formatted. Then we have the more familiar unordered lists, UL, which display items with bullet points by default.
Bullet points. Got it.
And ordered lists, AL, which use numbers or letters. You can control the marker type with the type attribute numbers, 1, uppercase A or lowercase a letters, Roman numerals, I or I.
Flexible.
Very. You could even set a starting number or letter with the start attribute and reverse the order of the list with the reversed attribute in HTML5. The compact attribute used to try and reduce spacing, but CSS handles that now.
Right, CSS for styling.
Exactly.
Yeah.
Definition lists, DL, are great for glossaries or key value pairs, using DT for the term and DD for the definition. DIR was intended for lists of directory titles, and menu displayed items simply one per line. Both less common now, usually replaced by UL.
Okay. And you mentioned scrollable lists.
Yeah, it's interesting that the notes mention the possibility of scrollable embedded lists, probably achieved through styling or maybe older, non-standard means, not a core HTML list feature itself.
Gotcha. Were there any HTML elements that were introduced but ultimately didn't become standard or just fell out of use?
Oh, definitely. Nexthead, from a really early version, HTML 0-day C, was intended as a way to automatically generate unique IDs for elements. Never really caught on, totally defunct now.
Huh. Interesting idea, though.
And IceIndex. That was used to signal that a document was a searchable index. It often displayed a prompt for keywords right at the top of the page. You'd type something in, hit enter, and it would query itself.
Wow. Built-in search functionality almost. Relics from the early web. Now, beyond just displaying static documents, the web quickly evolved to handle dynamic content, right? How did HTML adapt?
That's where server-side languages really took off. To pull data from databases, respond to user input, and show customized content, developers needed more than just static HTML.
So HTML needed help.
Exactly. Languages like ASP Active Server Pages from Microsoft, using .as files, CGI, the common gateway interface, often using .cgi scripts, and perhaps most prominently, PHP, that recursive acronym, Hypertext Preprocessor, using .php files.
PHP is still huge.
Absolutely. HTML would still provide the basic structure of the page, but these server-side languages running on the web server would handle the logic, database interaction, and generating the specific HTML sent to the user's browser.
So HTML became more of a template or framework for these dynamic applications. And with HTML5, we saw the introduction of new semantic elements, focusing on page layout and the meaning of content.
Precisely. This was a big step forward for clarity and accessibility. HTML5 introduced elements that describe the role of the content they contain. We got header for the introductory stuff at the top logo, site navigation, maybe a search bar, footer for the bottom, copyright, contact info, related links, article to represent a self-contained piece, like a blog post or news story, section to group related content together, maybe a chapter or a themed part of a page. It also helps with structure and often visual spacing. Nav, specifically for major navigation blocks. And main, to clearly define the primary content area of the page, distinct from headers, footers, and sidebars.
That makes so much sense. It helps both developers reading the code and things like search engines understand the page structure better.
Exactly. Much clearer than just using generic div elements for everything.
Definitely. What about elements introduced for more interactive features or embedding multimedia?
HTML5 brought in several key ones there too. Mark lets you highlight specific text, like search results. Dialog is for creating interactive dialog boxes or pop-up windows natively in the browser.
Oh, like modal windows.
Yeah, it provides the basic structure and accessibility features for them. Figures used for self-contained content like images, diagrams, videos, often with an optional fig caption right inside it to provide a caption.
Grouping the image and its description together semantically.
Exactly. Time is for representing dates and times in a machine-readable format, good for calendars or timestamps. Progress displays the completion status of a task, like a file upload. Meter shows a scalar value within a known range, like a gauge disk usage, vote results, that kind of thing.
Visual indicators built right in.
Yep. Details creates an interactive disclosure widget. You click a summary, and it reveals more content. Summary provides that visible heading for the details element.
Like an accordion panel.
Kind of, yeah. For displaying Asian language annotations, like pronunciation guides, there's Ruby, Cot for the annotation text itself, and RPOD to show fallback parentheses for browsers that don't support Ruby annotations. Bidirectional isolation helps isolate text that might be formatted in a different direction, like embedding Arabic or Hebrew within English text, preventing display issues.
That's quite specific, but important for internationalization.
Very. And iframe allows embedding content from other web pages. It gained important security attributes like sandbox to restrict what the embedded content can do. Seamless, though browser support varied and it's less used now, to try and make it look like part of the parent page, and artdoc to directly define the HTML content of the iframe within the attribute itself.
Iframe seems powerful, but also potentially risky if not used carefully.
Definitely. And finally, aside is for content that's tangentially related to the main content, like a sidebar, pull quotes, or maybe related links.
Wow, that's a significant expansion in built-in interactivity and multimedia capabilities. Were there also new attributes added to existing HTML elements to enhance interactivity?
Yes, several useful ones. The content editable attribute, when set to true on almost any element, allows users to directly edit its content right in the browser, like a mini text editor.
Whoa, really? Just like that?
Yep, surprisingly simple to enable. In JavaScript, document.activeElement can tell you which element on the page currently has focus, and document.hasFocus checks if the document itself has focus. For optimizing animations, there's request animation frame, which tells the browser you want to perform an animation, and requests that the browser schedule a repaint of the window for the next animation frame. This leads to smoother, more efficient animations compared to older methods like set timeout.
Better performance for animations. Good.
And while this particular document doesn't detail them heavily, HTML5 crucially introduced the dedicated video and audio elements for embedding video and audio content natively without plugins, a huge step.
Absolutely. No more relying solely on Flash for basic media playback. Now, for those really specific character-level styling needs, where you just want to style a single word differently.
That's where the span element is your friend. It's an inline container, meaning it doesn't break the flow of text like a P or div, and it doesn't have any inherent semantic meaning itself. Its main purpose is to group inline elements or text so you can apply styling via CSS or target them with JavaScript. Perfect for changing the color of one word, for example.
The go-to for small inline styling hooks.
Precisely. And HTML5 also coincided with and enabled significant advancements in CSS styling. CSS3, really. Things like box shadow for drop shadows using multiple backgrounds on a single element, styling borders with images using border image, creating rounded corners easily with border radius.
Border radius was a lifesaver. No more slicing corner images.
Tell me about it. Also, CSS animations and transitions became standard, handling text overflow gracefully, like showing an ellipsis, controlling hyphenation with hyphens, adding text shadows, and using custom web fonts with @FontFace.
@FontFace changed web typography completely.
Absolutely. It also strongly supported new layout methods like multi-column layouts and especially flexible box layout or Flexbox, and later CSS Grid, which revolutionized how we structure pages. And the document even highlights w3.css as a CSS framework designed to help create responsive designs layouts that adapt to different screen sizes more easily.
It sounds like HTML5 and CSS3 together really embrace the need for more visually rich, dynamic, and adaptable web experiences. Now, HTML doesn't operate in isolation, as we've discussed.
Yeah.
What are some of the key related languages web developers often use alongside it?
Yeah, several are tightly intertwined. We mentioned PHP already, a huge server-side language. VXML is the voice extensible markup language, specifically for creating voice-based interactions, like for automated phone systems or voice assistants.
Voice interfaces? Interesting.
XML, the extensible markup language, is more general purpose. It's less about display and more about structuring and transporting data in a flexible, self-describing way. It was, for a time, seen as a successor or stricter version of HTML in the form of XHTML.
Right, we'll get to XHTML. And the big one.
And of course, JavaScript. Originally known as ECMAScript, and briefly Mocha and LiveScript, it's essential for adding interactive behavior, manipulating the page after it loads, making requests for data, pretty much anything dynamic that happens in the browser.
Client-side scripting.
Exactly. We also had ActiveX for a while. That was a Microsoft framework allowing embedding of software components like media players or Office document viewers directly in Internet Explorer. But it had security issues and was very platform-specific, so it's now considered legacy technology, unsupported in modern browsers.
It's interesting how some technologies become mainstays while others fade away. And speaking of fading, it seems like some older HTML4 elements are now considered best practice to style using CSS rather than using the HTML elements directly. Why that shift?
That's a key principle of modern web development. Separation of concerns. HTML should define the structure and meaning of the content, while CSS should define its presentation or style.
Structure versus style.
Precisely. So elements that were purely presentational, like font to set, font face, size and color, or center to center aligned content, or for strike-through text, or big to make text bigger, these are all things CSS handles much better and more flexibly.
So using CSS is just cleaner and more powerful.
Yes. Other examples include Acronym and Apira, though Apira is still valid HTML5 for abbreviations. Its styling is CSS. Applet for embedding Java applets. The recommendation now is Object or other modern tech. Doer, use LL. Base font, CSS handles base font styles. And TT for teletype text. Use CSS for monospaced fonts. This separation makes code cleaner, more maintainable, easier to restyle, and generally better for accessibility.
Makes sense. And what about frames? They used to be everywhere.
Frames. The frame set, and no frames elements allowed you to divide the browser window into multiple independent scrollable sections, each loading a separate HTML document. They caused a lot of usability and accessibility problems and broke things like bookmarking. They're completely obsolete in HTML5. You'd use CSS for layout now, or maybe iframe carefully for embedding external content.
Good riddance to frame sets, maybe.
Many developers would agree. One last related thing the doc mentions is Navigator.Register Protocol Handler. It's a JavaScript API that allows web applications to register themselves as possible handlers for specific URL protocols like Mailto, or custom ones like Web plus Calendar.
Interesting. Letting web apps act more like native apps.
Okay, let's circle back to that canvas element for a moment. It was described as most hyped. Beyond just drawing graphics, what really made it generate so much excitement?
I think the core excitement came from its potential to enable rich, truly interactive experiences directly within the browser without needing users to install third-party plugins like Flash, Silverlight, or Java applets.
Getting rid of the plugin barrier.
Exactly. While basic scripting in HTML had existed before, Canvas offered a standardized, performant, and dedicated container specifically designed for programmatic drawing using JavaScript. It gave developers a blank slate, a pixel-level drawing surface they could fully control with code.
Opening the door for things like complex in-browser games, sophisticated data visualizations, photo editors, interactive simulations, artistic tools. Things that were previously very difficult or impossible to do well with just standard HTML and CSS, or required plugins.
So it wasn't doing the visual rendering itself, but providing the dedicated space in the API for JavaScript to manipulate pixels. What does the basic HTML for a Canvas element look like?
It's actually very simple. The basic tag is just canvas. You'll almost always give it an id attribute, like id my drawing canvas, so your JavaScript code can easily find and target it.
Need a handle to grab onto it.
Right. You also need to set its dimensions using the width and height attributes directly on the tag, like canvas id my canvas with 500 height 300. It's important to use the attributes, not just CSS, to set the actual drawing surface size. CSS width and height will just scale the existing canvas.
Good distinction. Width and height attributes define the pixel grid.
Exactly. You can also use the standard style attribute for visual styling, like adding a border style border.1px solid black, just so you can see where the canvas is on the page.
And the drawing happens with
JavaScript. You'll typically have a script block either embedded in the HTML, often near the end of the body, or linked as an external file using the src attribute of the script tag. That script grabs the canvas element by its ID, gets its rendering context, usually the 2D context, and then uses the context to drawing commands.
Got it. Are there any key considerations or best practices when working with Canvas?
Yeah, a few things. You can actually layer multiple canvas elements on top of each other using CSS positioning. This can be useful for separating different visual elements, like a background layer and a character layer in a game, for performance.
Stacking canvases. Interesting.
The default size of a canvas, if you don't specify width and height, is 300 pixels wide by 150 pixels high. Just good to know. And while Canvas is incredibly powerful, one of the initial and ongoing challenges was, and sometimes still is, ensuring consistent behavior and performance across different web browsers and devices. That's a common theme, though.
Browser compatibility, the bane and challenge of web development. Now, we've established CSS and JavaScript as essential companions to HTML5. Could you just briefly recap their primary roles?
Sure. CSS, cascading style sheets, is fundamentally the styling language. It dictates how the elements of document languages like HTML, XML, SVG, etc. are visually rendered and presented. Colors, fonts, layout, spacing, animations. That's CSS's job. It's evolved through versions CSS1, CSS2, CSS3, CSS4, now being worked on, and its standard identifier online is the MIME type text checks.
All about the looks and layout.
Pretty much. JavaScript, on the other hand, is the behavior language. It's a full-fledged scripting language, quite powerful, with a syntax often compared to C++ or Java. Its primary role in web dev is adding interactivity or responding to user actions, clicks, key presses, changing content dynamically after the page loads, fetching data from servers without reloading the page, AJAX, validating forms, controlling multimedia, all the dynamic stuff.
So, CSS for the look and feel, JavaScript for the brains and interactivity. How does JavaScript typically interact with the underlying HTML document it's running alongside?
It has several common ways. Document.write can directly insert content into the HTML while the page is being parsed and loaded, but it's generally discouraged now as it can overwrite the whole page if used incorrectly after loading.
Okay, maybe avoid that one mostly.
Yeah. More commonly, you use the DOM document object model API. JavaScript can access any element on the page, read its attributes, change its content using the inner HTML property, which lets you inject HTML or text content for just plain text, change its style attributes, add or remove elements entirely. Full control, really.
Manipulating the DOM, that's key.
Absolutely. For simple user feedback, window.alert creates those basic pop-up message boxes. Useful, but can be annoying if overused. And console.log is absolutely invaluable for developers. It writes messages, variable values, debugging info to the browser's developer console, invisible to regular users, but essential for figuring out what your code is doing.
Console.log is a developer's best friend.
You know it.
Useful tools. Are there any inherent limitations or potential pitfalls when using JavaScript heavily?
Well, JavaScript itself doesn't have built-in functions for, say, directly accessing the file system, or complex printing capabilities like a desktop application, might for security reasons, mostly.
Yeah.
It operates within the browser's sandbox.
Security sandbox. Important.
Very. It interacts heavily with the browser object model, or BOBO, which gives access to browser features like the window, history, location bar. Developers also need to be mindful of performance. Complex JavaScript can slow down pages or drain battery on mobile devices. And issues like memory leaks, where the script holds on to memory it no longer needs, can occur if code isn't carefully managed. And, of course, security is paramount. Cross-site scripting, XSS, is a major vulnerability class where malicious scripts get injected into websites, so sanitizing user input and being careful about how you manipulate the DOM is crucial.
Right. Performance, memory, security, all key considerations for robust web applications. Now, the document also touches on some more cutting-edge tech like A-frame and polyfills. What are these, and what problems do they aim to solve?
A-frame is pretty cool. It's a newer framework that uses an HTML-like syntax custom tags, essentially built on top of JavaScript and technologies like WebG WebXR, specifically designed to make creating virtual reality experiences in the browser much easier.
VR in the browser using HTML tags.
Sort of, yeah. You write things like a scene, a box, a sphere, set attributes for position, rotation, color, and A-frame handles the underlying 3D rendering and VR setup.
What's neat is you don't necessarily need a dedicated VR headset. It often works on regular desktop screens and mobile phones too, as long as the browser supports the underlying tech. It lowers the barrier to entry for creating 3D and VR web content.
Fascinating. Democratizing VR dev a bit. What about polyfills? The name sounds like they're, well, filling in gaps. You nailed it. A polyfill, sometimes called a shim, is essentially a piece of code, usually JavaScript, that provides modern functionality in older browsers that don't natively support it.
Like a patch for old browsers.
Exactly. So let's say there's a new HTML5 feature or a modern JavaScript function that works great in the latest Chrome and Firefox, but not in, say, an older version of Internet Explorer. You can include a polyfill library in your website's code. That library checks if the browser lacks the feature, and if so, it implements a version of it using older supported techniques.
So developers can write modern code but still support older browsers.
That's the goal. It allows you to use newer web standards while gracefully degrading or providing the functionality for users on older platforms. For instance, the Frame.js library we just mentioned could be seen as acting like a polyfill for browsers that don't natively support WebXR yet.
But there's a catch, right?
Yeah, the main catch is that polyfills rely on JavaScript being enabled in the user's browser. If someone disables JavaScript for security or other reasons, any functionality provided solely by polyfills won't work. So it's often good practice, if possible, to ensure the site still offers some basic usability, even without JavaScript, though that's increasingly difficult for complex web apps.
So a way to bridge the gap, but with that JavaScript dependency. Now, we saw a brief comparison earlier of HTML5 and XHTML5. What's the core distinction? They sound similar.
They are very similar in terms of the elements and capabilities they offer, but the key difference lies in the syntax rules. XHTML is essentially HTML rewritten to follow the stricter, more rigid rules of XML, extensible markup language.
Stricter rules, like what?
XML is very fussy about structure. So XHTML requires things like all element names and attribute names must be in lowercase, all attribute values must be enclosed in quotation marks, either single or double, and crucially, all elements must be properly nested and closed. Even elements that are typically empty in HTML, like brief for a line break or MBU for an image, must be explicitly closed in XHTML.
How do you close an empty tag?
Use a self-closing slash before the final angle bracket. So brie in HTML becomes brie in XHTML. An image tag would be image src image.jpg alt description.
Okay, so much stricter syntax. Why bother with XHTML then? What was the appeal?
For a while, especially around the early 2000s, XHTML was seen by many, including the W3C for a time, as the future of the web. The idea was that the stricter XML rules would lead to cleaner, more well-formed code, which would be easier for browsers and other tools like automated processors to parse reliably. It enforced what many considered good practice.
More predictable, less room for browser guesswork.
That was the theory. However, it also meant that even tiny syntax errors could cause an SHTML page to fail to render completely in some browsers, whereas regular HTML browsers are generally very forgiving of errors. In the end, the more pragmatic, error-tolerant approach of HTML5, driven largely by the U282G group, Web Hypertext Application Technology Working Group, won out for mainstream web development. Though XHTML5 still exists as a standard if you want to use that stricter XML serialization.
So HTML5 is more forgiving, XHTML5 is stricter XML style. Got it. Now, the document also touches on some of the enduring challenges web developers face. What are some of the fundamental difficulties in just building websites today?
Oh, where to start? I think one of the biggest, most persistent challenges is the sheer diversity of the landscape you have to cater to. You've got users on desktops, laptops, tablets, phones, even smartwatches and TVs now. They're using different browsers, Chrome, Firefox, Safari, Edge, and older versions too. They have varying screen sizes, resolutions, internet connection speeds, and accessibility needs.
Creating something that works well for everyone sounds almost impossible.
It's definitely a huge challenge. It's this constant balancing act. You want to use the latest, coolest features to create dynamic, engaging experiences, but you also need to ensure the site is still usable, accessible, and performs reasonably well on older browsers or less powerful devices or slow connections.
The trade-off between cutting edge and compatibility.
Exactly. And performance is absolutely critical. The document includes that striking quote, "For every second the page loads, you will lose about 10% of the viewers."
Wow, 10% per second. That's brutal.
It really highlights how impatient users are online. Speed matters a lot. If your site is slow, people just leave.
Online attention spans are notoriously short. There's also a quote from Lao Tse. All difficult things in the world are sure to arise from a previous state in which they were easy. How does that relate to web user experience?
I think it connects to the idea of avoiding unnecessary friction or complexity for the user. Don't make things harder than they need to be. For example, if someone wants to buy something, don't force them through a mandatory multi-step sign-up process before they can even decide if they want the item. Make the core task easy first. Don't erect artificial barriers that frustrate users and make them give up.
Smooth out the user journey. Remove those hurdles. Makes perfect sense.
Yeah. And then there's that memorable phrase, bleeding edge of the past is legacy of today. What's the core message there? That's a fantastic way to put it. It's just a stark reminder of how incredibly fast technology changes in this field. What was the absolute latest must-use tech just a few years ago, like ActiveX we mentioned earlier, used heavily in 1996 and 2015, can quickly become outdated, unsupported, and even a liability.
What was standard yesterday might break your site tomorrow.
Pretty much. Future browsers might drop support for it. Security vulnerabilities might be discovered that never get fixed. So developers always need to think about the longevity of the technologies they choose. Will this still be supported in 5 years? What's the migration path if it's not? It also ties back to knowing your audience. Are they likely to be using older browsers or devices where this bleeding edge tech won't work?
So important to consider the whole life cycle.
Absolutely. And the inclusive design philosophy quote mentioned from Arooka.com reinforces this build for the majority. Consider desktops, laptops, tablets, phones. Think about future, modern, and past hardware. Design inclusively.
Inclusivity and future-proofing, definitely crucial. Now, even before writing code, there are big design considerations. What are some key things to think about right at the start, at the design stage?
The absolute #1 thing before anything else is know your audience. Who are you building this for? What are their needs, their goals, their technical capabilities, the context in which they'll be using the site? Everything flows from that understanding.
Audience first. Always.
Always. And there's no single correct design methodology that works for every project. You need to be flexible, adaptable. The document uses the phrase flow like water, which I like. Be prepared to adjust your approach based on the project's specific needs and constraints.
Adaptability is key.
And you also need to consider the balance between pure usability, making things easy and efficient to use, and maybe a more flashy, visually impressive design. The right balance depends entirely on the context. An internal business tool probably prioritizes usability, while a marketing site for a creative agency might lean more towards visual flair. It's a spectrum.
Context dictates the balance.
Okay.
Got it. Now, the document provides some basic examples of HTML5 code, including using that canvas element. Could you walk us through a couple?
Sure. There's a super basic HTML5 structure shown, really just the boilerplate. Dorsey typey HTML, HTML head and body, with a simple paragraph inside saying, Arooka HTML5 is awesome.
Yeah.
Centered using some inline styling, just shows the bare minimum.
The hello world of HTML5 pages.
Oh, pretty much. Then there's an example that just includes an empty canvas tag within the body. Nothing drawn on it yet, just the element itself placed on the page.
Setting the stage.
Right. Then a slightly more useful example shows how to provide fallback content inside the canvas tags. This content is only displayed if the user's browser doesn't support the canvas element.
Graceful degradation.
Exactly. You could put a simple message like, sorry, your browser doesn't support canvas, or even an MD tag pointing to a static image that conveys similar information. M is GSRC, fallback image.jpg alto. So users on older browsers still get something meaningful.
Good practice. And what about the code to actually draw something simple on the canvas?
There's an example showing the basic steps to draw a single straight line using JavaScript. It's typically done in these steps.
Okay.
1. Get a reference to the canvas element in your HTML, usually using its id with document.getElement beyond it my canvas. 2. Get the 2D rendering context from the canvas object, like canvas.getContext 2D. This context object holds all the drawing methods.
Got the canvas, got the drawing tools.
3. Use the context's methods. To draw a line, you might use context.beginPath to start a new drawing path, context.moveTo by 1y1 to set the starting point coordinates, context.line2 by 2y2 to define the line's endpoint, and finally context.stroke to actually make the line visible on the screen with the current stroke style, color, width, etc.
Move to line to stroke. Seems logical.
It is, once you get the hang of it. And it's important to remember, as the example shows, the script tag containing this JavaScript code is usually placed either in the head, if deferred or carefully managed, or, more commonly, just before the closing body tag. It needs to run after the canvas element exists in the DOM. The script refers to the canvas using its ID.
Placement matters.
Definitely. There's also an example showing how a typical HTML5 page might link to external files for its styling. Link.leal's stylesheet href stylesheet.css in the head, and its JavaScript behavior. Script src script.js script often before body. This separation concerns HTML for structure, CSS for style, JS for behavior, is highly recommended for keeping projects organized, maintainable, and promoting code reuse. It can also offer caching benefits and sometimes security advantages.
Separate files. Best practice for anything beyond tiny examples. Okay, shifting focus a bit, the document explores how we view documents online, the evolution there. What were some main challenges moving from paper to digital?
Well, initially, online documents were mostly just plain text. Think early emails, news groups. They lacked the layout, fonts, images, and general visual richness we expect today. So there was this constant drive to find better ways to present formatted content online.
Beyond just text files.
Right. The key challenges revolved around a few things. File size, how to make documents downloadable over slow connections, content security, how to prevent easy unauthorized copying or modification, and ease of use, ideally, letting people view documents without needing to install lots of special software or plugins for every different format, like Word docs, spreadsheets, etc.
Yeah, the you need to install X reader problem. We've all been there. And eventually, PDF became the dominant solution, didn't it?
Yes, Adobe's portable document format, PDF, really emerged as the de facto standard for sharing documents online in a way that preserved the original formatting across different platforms. It solved the layout problem pretty well.
But it wasn't perfect, right? The document mentions drawbacks.
Correct. Even PDF had, and still has, its issues, especially for online viewing. File sizes can still be large, especially for image-heavy documents. It often requires users to have Adobe Reader or compatible viewer installed, or rely on built-in browser PDF viewers, which can vary in quality. Security is complex. While PDFs can be password protected, the content itself, especially text, can often still be copied easily unless more advanced restrictions are applied. And historically, making the content inside PDFs easily searchable and indexable by web search engines was a challenge, although that has improved over time.
So, good for preserving layout, but maybe not ideal for web-native content consumption. The document mentions an interesting alternative attempt by Blue Pacific Software. Flash printer, Flash paper.
Yes, Flash paper.
Yeah.
That was a clever idea back in the day when Adobe Flash was ubiquitous. Blue Pacific Software developed Flash printer, later rebranded FlashPaper after Macromedia acquired them, and then Adobe acquired Macromedia.
Okay, so it ended up with Adobe eventually. What did it do?
It installed itself as a virtual printer driver on your computer. You could print any document from any application to this Flash printer, and instead of paper output, it would generate a file in the Flash SWF format.
So turning any document into a Flash movie?
Essentially, yes.
Yeah.
A multi-page Flash movie that looked just like the original document. The advantages were that the resulting SWF files were often quite small, they could be easily embedded in a web page, and viewed by anyone with the Flash Player plugin installed, which was almost everyone back then. And because the text was rendered as vector graphics within Flash, it was harder to directly select and copy than text in a standard PDF, offering some basic content protection.
Interesting approach. Why didn't it stick around?
Well, it relied entirely on the Flash plugin. As web standards evolved, particularly with HTML5, CSS3, and JavaScript becoming more powerful, and as security concerns and performance issues plagued Flash, especially on mobile, the reliance on plugins decreased dramatically. Apple famously refused to support Flash on iOS. Eventually, Adobe itself deprecated Flash Player. So, technologies like FlashPaper that depended on it naturally faded away too.
A casualty of the move away from plugins towards open web standards. So the quest for better online document viewing continued. What are the ongoing efforts?
Because of those lingering limitations of PDF and the demise of plugin solutions, the development of custom-made document viewers, often built using HTML, CSS, and JavaScript, remains an active area. The goals are still largely the same. Overcome browser compatibility issues, eliminate plugin dependencies, enhance content security, though this is inherently hard on the web, and improve search engine indexability and accessibility.
Building viewers of web tech itself.
Exactly. And the document we're looking at actually includes examples of 2 different custom content viewer approaches developed by Arooka, which gives a practical glimpse into these efforts.
Okay, let's look at those. Content Viewer version 1 from the Arooka reference library. What was its concept?
This one was described as a more advanced application, specifically for displaying book content, likely paid content from their library. It emphasized security features and used a tabbed interface for navigation between different sections or books. A key aspect was that it was ad-supported, which added complexity.
Ads and security. Interesting mix. What were the technical details?
Okay, looking at the code snippets, it used no script to redirect users without JavaScript to an error page, a common technique. It had a meta HTTP equiv refresh tag to automatically load an aid.html page after 380 seconds, presumably displaying ads periodically.
Auto-refreshing ads. Okay.
For security, it included JavaScript functions, click E, click an S, aimed at disabling right-clicking, trying to prevent saving images or viewing source. It also used a meta tag, meta HTTP EYV image toolbar content. No, specifically to disable Internet Explorer's image toolbar that appeared on hover, plus a robots meta tag, no image index, to discourage image indexing by search engines.
Trying hard to lock down the content.
Seems so. The code also specified character set, keywords, author, basic colors directly in HTML. It had JavaScript attributes on drag start, on select start, trying to disable text selection and dragging. It linked to external JS, arookatabber.js, for the tab functionality, and separate CSS files for screen, arookaservices.css, and print, arookaprint.css.
Separate print styles. That's good practice.
Yes. It used JavaScript to initially hide the tab content, structured with divs having the class tabber. The main tab had welcome text and a link to buy more time. It explicitly listed browser compatibility, mentioning partial support in older browsers, and technical requirements no Flash HTML5 needed, but JS must be enabled. It relied heavily on iframes to load the actual content for the subsequent tabs, Jinchan, 7 days, etc., each behind a click here to load content link. It included a no frames fallback. And finally, a loading bandwidth warning and a JavaScript close window link.
Wow, quite a complex setup for its time. Lots of JavaScript tricks, reliance on iframes, and manual browser compatibility notes. What about Content Viewer version 2? How did that differ?
Version 2 took a much simpler structural approach. It used basic CSS to create a fixed left sidebar, divide left, containing internal links, #anchor name. These links pointed to named anchors, a name, anchor name, placed within the main content area on the right. Divide right.
Like an internal table of contents linking to spots on the same page.
Exactly. And the content displayed on the right side, in this example, primarily consisted of just images, MDGSRC. The CSS for the fixed positioning, widths, heights, and background colors of the 2 divs was included directly in a style block in the HTML head.
Much simpler. What kind of content was linked?
The links in the left sidebar example included things like cover, EMAG news, artist names, budget space, awards, crossword puzzle, etc., plus a home link and a copyright notice at the bottom. So mostly navigation for what seemed like an online magazine made of images.
A very straightforward layout using basic HTML anchors and CSS positioning displaying images, a big contrast to version 1's complexity. Now, the document also delves into scalable vector graphics, SVG. How does SVG fit into displaying content online, especially compared to formats like JPG or PNG?
SVG is fundamentally different. While JPG, PNG, GIF are raster formats, grids of pixels, SVG is a vector format. It's an XML-based language used to describe two-dimensional graphics using geometric shapes, lines, curves, rectangles, circles, text, and filter effects mathematically.
Math instead of pixels. What's the main advantage?
Scalability. Because it's described mathematically, an SVG image can be scaled up or down to any size tiny icon or huge billboard without losing any quality. It never gets pixelated or blurry, unlike raster images when you enlarge them too much. This is huge for responsive design, where graphics need to adapt to different screen sizes and resolutions.
Sharp graphics at any size. That's a big plus. Any downsides?
Well, while development started back in 1999, consistent and performance support across all browsers for all SVG features took time. Very complex SVGs, especially those with lots of intricate paths or filters, can sometimes be more processor-intensive to render than a comparable raster image. And for photographic images, raster formats are still generally better suited. But for logos, icons, illustrations, charts, diagrams, SVG is often ideal. It's also being pushed as a modern alternative to Flash for vector animations.
Makes sense. You mentioned layout control within SVG itself can be tricky. How do you position things?
Yeah, arranging complex layouts purely within SVG using just its own coordinate system can be less intuitive than using HTML and CSS. Often, developers will embed an SVG within an HTML page and use CSS to position the SVG container itself. However, SVG does have powerful internal tools for transforming elements. The transform attribute is key. It lets you apply functions like translate XY to move things, rotate angle to rotate, scale factor to resize, skew X angle or skew Y angle to skew, or even complex matrix transformation.
So you can move, rotate, scale things inside the SVG.
Absolutely. You also have the concept of the viewport, the visible rectangular area of the SVG on the page, and the viewbox attribute. The viewbox defines the internal coordinate system of the SVG graphic itself. For example, 0, 0, 100, 100 defines a coordinate system from 0, 0 to 100,000, 100. The preserve aspect ratio attribute then controls how that viewbox is scaled and aligned to fit within the viewport.
Controlling how the internal drawing scales to fit the container.
Exactly. Options like none allow stretching. Xmid meet, the default, scales it down to fit entirely while preserving aspect ratio and centering it. Xmid lead slice scales it up to fill the whole viewport while preserving aspect ratio and centering, potentially clipping parts. It gives you fine-grained control over scaling behavior. Note a negative width height in VBox aren't allowed, and a 0 width height disables it.
Lots of control there. How are the actual shapes and lines drawn? Is it complex?
The workhorse for arbitrary shapes is the path element. Its D attribute contains a mini-language of commands and coordinates. Things like M Luvido, L Lineado, H horizontal Lineado, V vertical Lineado, C curvado cubic Bezier, S smooth curvido, Q quadratic Bezier curvado, T smooth quadratic, and A elliptical arc followed by coordinates.
Sounds potentially very complex to write by hand.
It can be. While you can draw simple paths by hand for complex illustrations, developers almost always use vector graphics editors like Adobe Illustrator, Inkscape, which is free and open source, Figma, or Sketch. These tools let you draw visually and then export the result as clean SVG code, including those complex path definitions.
So design visually, export the code. Makes sense. Can you animate these SVG graphics? Make them move?
Oh yes. SVG has powerful built-in animation capabilities, primarily through a specification called NZIL, Synchronized Multimedia Integration Language. You can also animate SVG elements very effectively using JavaScript, often in conjunction with CSS.
Smellvile, what does that let you do?
Smellvile allows you to declaratively define animations right within the SVG code itself. You can specify how attributes of SVG elements should change over time. For example, you can animate an element's position, XY, size, with height, color, fill, stroke, opacity, or even its transformation attributes. Transform. You can animate text, embedded raster images, vector shapes, pretty much anything.
Declaring animations in the code.
Right. It's quite powerful. Because SVG is rendered and animated by the browser together, you can create dynamic, interactive visuals. While the basic animations are linear, moving from A to B at constant speed, Smellvile provides ways to control timing, begin, dur, end, repetition, repeat count, repeat, dur, and pacing using calc mode and key time ski splines for more sophisticated easing effects.
What are some basic Smela animation commands?
The core ones include animate, which modifies a single attribute over time. You specify attribute name from value to value duration. Set, which changes an attribute to a specific value after a certain delay. Begin. Animate motion moves an element along a predefined path shape over a duration, optionally rotating the element to follow the path direction. Rotate. Animate color is specifically for transitioning colors, though animate can do this too. An animate transform animates one of the transform functions, like rotation, type rotate, specify from and to angles, dirt. You often see repeat count indefinite to make animations loop forever.
Seems quite comprehensive. The doc has an animated example.
Yes. It shows a text element continuously rotating using animate transform type rotate, repeat count indefinite. It also shows a circle moving back and forth horizontally, but that part is actually done using JavaScript, not SmellAway. The JavaScript uses setInterval to repeatedly call a function that gets the circle's current CX, center X attribute, calculates a new position, and uses setAttribute to update it, creating the motion. Shows both approaches are possible.
Good illustration of both declarative setML and imperative JavaScript animation with SVG. Now, what about defs and use? They sound like they're for reuse.
Exactly. Code reuse is crucial for efficiency and maintainability. The defs element, short for definitions, acts as a container where you can define graphical objects that you intend to reuse later, but you don't want them rendered immediately. You define something inside defs, like a complex shape, a gradient, a filter, or a group of elements, and give it a unique arty attribute.
Like defining a template.
Precisely. Then, elsewhere in your SVG document, wherever you want to actually display that object, you use the use element. The use element points to the defined object using its xlink.href attribute, or just href in newer SVG versions, referencing the IDE example xlink.href hashtag my defined shape. You can then position, scale, or style each instance created by use independently. It saves a ton of code repetition if you have identical elements appearing multiple times. The doc shows defining a blue rectangle in defs and then using it twice at different spots.
Very useful for repeating elements like icons or pattern components. Can you play audio with an SVG too?
Yes, you can. SVG includes an audio element, similar in concept to the HTML5 audio tag, allowing you to embed and control audio playback directly within the SVG document itself.
How does it work?
You use attributes like xlink.href or href to specify the path to the audio file, type to give the MIE type if needed, and audio level to set the volume. Crucially, you can control playback using timing attributes like begin. You could set begin ORs to play immediately, or begin myshape.click to start playing only when the user clicks on an element with the ID myshape. You can also use repeat count to loop the audio.
So interactive graphics with triggered sound effects right within the SVG. Interesting. The document also mentions Data Uniform Resource Identifiers, DURIs, for embedding SVG. What's the idea there?
A DURI, more commonly called a data URL, is a scheme for embedding small files or pieces of data directly in line within other code, instead of linking to them as external resources. For SVG, this means you can take the entire text content of a .svg file, encode it, usually using base64 encoding to handle special characters safely, and embed that resulting long string of data directly into your HTML or CSS.
Embedding the SVG code as a string, why do that?
A few potential reasons. One is performance. It can reduce the number of separate HTTP requests the browser needs to make to load the page, as the image data is part of the main HTML or CSS file. This can be beneficial, especially for small icons. Another reason is portability or encapsulation. The graphic becomes self-contained within the document. It can also offer a very minor degree of obfuscation against casual right-click saving of the image file, though the code is still viewable in the source.
How would you use one?
You can use a data URL wherever you normally put a file path. For example, in an HTML MMG tag, MMG src data.imagesvg plus XML base64 phn2 zyb, where the SU is the base64 encoded SVG code, or in CSS for a background image.url data.imagesvg plus XML base64 phn2 zyb, or even in an object tag's data attribute. The document shows examples of these.
Got it. Fewer requests, but potentially larger HTML CSS files. The doc then shows a complex example, a cover page rendered as JPG, linked SVG, and embedded SVG code. What were the takeaways?
That comparison highlighted SVG's core strength: scalability without quality loss. The SVG versions looked sharp regardless of zoom level, unlike the JPG, which would pixelate. However, it also noted that rendering very complex gradients smoothly can sometimes be a challenge for SVG compared to a raster format optimized for photos like JPG. But for graphics without such gradients, SVG, either linked or embedded as code, is often superior. The embedded code version offered that slight anti-copying benefit, but made the HTML source much larger. The linked SVG kept the HTML cleaner. It also reiterated the potential drawback of inconsistent layout engine support for very complex SVG features across all browsers, though this has improved significantly. The example included a very long snippet of the actual SVG code for the cover page to illustrate the verbosity involved in defining complex graphics this way.
A practical trade-off analysis. Scalability versus complexity versus file size versus rendering nuances. Good comparison.
Okay, let's shift to transpub and Arooka transcopy. These sound like philosophical concepts about content sharing. They are, yeah. Transpublication, or transpub, is presented as this idea or philosophy about how to ethically and functionally incorporate content from other sources into your own work online. The core principle is that you should always provide clear, direct links back to the original source.
Just basic linking and attribution.
It goes a bit further conceptually. The ideal envisioned by proponents like Ted Nelson, who coined hypertext, involves transquotes, where the content isn't just copied, but is dynamically pulled directly from the original source and displayed within your document, maintaining a live link. This ties into the idea of transcopyright, suggesting that if you're transquoting and clearly attributing, you're not making a static copy, which might navigate traditional copyright issues by potentially enabling micropayments back to the original author for the use.
Wow. Dynamically pulling content and maybe paying for it automatically sounds ambitious. What are the challenges?
Oh, huge challenges, philosophically and practically. Firstly, reliably identifying the single original author or source over time across cultures, remixes, and translations is incredibly difficult, maybe impossible sometimes. Secondly, the legal frameworks around copyright, derivative works, and fair use are complex and vary globally. The transcopyright model doesn't neatly fit into existing law and relies on technology and agreements that largely don't exist. Thirdly, the document suggests the underlying payment model might not foster harmony, raising questions about originality and ownership. While acknowledging sources is good, the proposed implementation seemed very idealistic.
So a fascinating idea, but maybe ahead of its time or facing fundamental hurdles. How was it implemented practically in the examples?
The document describes the current crude implementation as simply using standard HTML ahref tags to link back to sources, potentially with CSS classes, class L, class I, and class red, to visually highlight text from different origins. It shows an example linking phrases to Xanadu, Arooka.com, and an author, Arooka, using target context and rev original context. It also mentions saving these files as .tqhtml, which would likely cause server compatibility issues. So the practical version shown is just basic hyperlinking with some extra attributes and styling conventions.
Just styled links, really. What about Arooka transcopy? How's that different?
Arooka transcopy is presented as Arooka's specific technical implementation for displaying content from a third-party website directly within a frame on another website. It uses a positioned iframe. The key difference from Transpub's ideal is that you're not integrating the content into your documents flow. You're embedding a live view of the other website within a box on your page.
It's like embedding a YouTube video, but for a whole web page section.
Exactly. The document suggests this might be the first real use of transcopy, right? Because you're not making a copy. You're displaying the original source live. The example shows using an iframe with specific inline style attributes for positioning and size, scrolling no, pointing its src to the 7c.gov.cn website. Yeah. It's a much more technically feasible approach than true transclusion, though it relies on the source site allowing itself to be iframed, which many sites block now for security reasons like click checking.
Iframing content. Got it. More practical, but with its own limitations. Now the document shifts gears dramatically, providing a huge overview of the web search landscape, looking way beyond just Google.
Yeah, it's quite an extensive list. It really underscores that while a few giants dominate search, there's been and continues to be a vast and incredibly varied ecosystem of search tools and approaches.
What kinds of diversity does it show?
It lists search engines that are now defunct, like Groker, Volunia, Hakia, Cartu, showing the turnover in the field. It includes open source, peer-to-peer options, Vereo, Seeks, Yasi, privacy-focused ones, DuckDuckGo, Startpage, Brave Search, map-based search, Wikimapia, Mappy, and tons of specialized engines.
Specialized like,
Shopping comparison, Google Shopping, GasBuddy, NextTag, Q&A sites, Yahoo Answers, Wolfram Alpha, educational resource finders, RefSeek, Suite Search, and a huge number dedicated to scholarly and academic literature. Google Scholar, CiteSeerX, PubMed Central, Base, Core, Science Open, Scopus, SpringerLink, WorldWideScience.org. Also lists visual search engines, meta search engines, Dogpile, Metacrawler that query multiple engines at once, anonymous search, multilingual search, internet search, and even examples of custom search engines built using Google's infrastructure, but focused on specific topics like medical search or environmental search.
wow. It's a powerful reminder that for specific information needs, the best tool might not be the biggest, most general-purpose search engine. There's a whole world of specialized search out there.
Absolutely. And it also lists resources for search engine optimization SEO professionals like Search Engine Land, Moz, SEMrush, Ahrefs, showing the whole industry built around understanding and influencing search results.
A very comprehensive look at the search world. Then, moving to a more serious topic, the document brings up the era of spooks and web privacy.
Right. This section directly confronts the modern reality of surveillance, both governmental and potentially corporate, where individual online activities are monitored and analyzed, often automatically, to assess potential threats or for other purposes.
It includes a prominent quote.
Yes, a significant quote attributed to Edward Snowden from June 2013, talking about the NSA's capabilities and approach. The quote highlights the idea of mass surveillance collecting and analyzing basically everyone's communications by default, the increasing ability to store this data indefinitely, and the chilling potential for this stored, initially innocent data to be reanalyzed later and used against someone if they fall under suspicion in the future, even if they've done nothing wrong.
A very sobering perspective on the implications of mass data collection.
Definitely. The document connects this theme to a 2015 source called Metamodal Metaphors in Cognition Intelligence, suggesting deeper analysis in that work. And as a concrete artifact of the web's security infrastructure, which is related to privacy and trust, it even includes the full text content of an SSL certificate from catalog.archives.gov.crt, showing the kind of information used to secure web connections.
A stark reminder of the privacy landscape we navigate online. Now, to give even deeper historical context, the document steps way back, pre-web, looking at early communication experiments.
Yeah, it's fascinating context. It briefly touches on milestones like Gian Domenico Romagnosi's 1802 observation of electric current affecting a magnet, a precursor to electromagnetism, some early, maybe unverified telegraph ideas from Francisco Salvacampillo and Francis Ronalds in the early 1800s. Paul Constat's, Schilling's work on insulated wire for underwater cables, 1812, and his needle telegraph, 1828.
Laying the very first groundwork.
Exactly. Then Samuel Morse's crucial telegraph patent in 1838. Alexander Vane's 1843 patent for document telegraphy, basically an early fax machine. The first teleprinter line between Philly and NYC in 1849. The first submarine cable between England and France in 1851. Frederick Bakewell demonstrating an image telegraph in 1851. David Edward Hughes's printing telegraph system in 1855.
Faster communications, sending images. The seeds were sown early.
And then jumping to wireless. Reginald Fessenden transmitting audio-speech wirelessly in December 1900 using a spark transmitter, and his request to General Electric in 1906 for a high-frequency alternator, built by Alexanderson, which enabled his two-way transatlantic wireless Morse code transmissions in January 1906. Just amazing foundational work.
It really puts the information age in perspective, decades, even centuries of building blocks. How does this connect more directly to HTML's precursors?
The timeline then bridges this history to the development of markup languages and networks. It highlights IBM's Generalized Markup Language, GML, in 1969, a direct influence on SGML, the start of email on ARPANET in 1971, the development of ARPANET router code, TCP specifications, and the X.25 protocol in the early 70s, the Cyclades network in France, 1973, IBM's SGML itself in 1974.
GML, SGML networks. Getting closer.
Right. Then interesting side notes like the Colossal Cave adventure game, 1975, as an early inspiration for hyperlinking. The Defense Communication Agency taking over ARPANET, Telenet Inc. being set up, CSNet in 1981, the crucial proposal for the domain name system, DNS architecture in 1983, and ARPANET switching fully to TCP/IP on January 1st, 1983, the birth of the modern internet, arguably. Client server developed in 84, Mailnet splitting off.
DNS and TCP/IP fundamental internet infrastructure.
Absolutely. Then HyperCard on the Mac in 1985-87, using Link virtual cards, a very influential early example of hypermedia. SGML becoming the official ISO standard 8879 on October 15, 1986, ARPANET being decommissioned in 1990, And then Tim Berners-Lee developing hypertext.am September 90, the very first HTML versions, HTML is already around 92. And from there, the rapid evolution we discussed. HTML1, HTML plus A, HTML 2.0 through 4.0 and 1, the W3C's push towards XHTML 1.0, the W2G continuing HTML development leading to HTML5, both W2G and W3C versions, and even HTML 5.1. It also notes key internet governance events like WSIS, IGF, NetMundial, and the WikiLeaks Vault 7 release 2017 related to digital security.
A whirlwind tour, but it really shows that progression from basic concepts to the complex web we have now. Now, behind the scenes, when we view a page, software in the browser renders it. These are the layout engines, right? The document lists a ton.
Yes, layout engines, or rendering engines, are the core software components inside web browsers responsible for taking the HTML markup, CSS styles, images, etc., and drawing the visual representation of the web page on your screen. The document provides an impressively extensive list, categorized in various ways.
What are the main categories?
It lists text-only engines, used by browsers like Lynx, and the original World Wide Web browser. Graphical engines are the ones we're most familiar with. GTK HTML, Presto, used in older Opera, Tasman, older Mackie, Gecko, Firefox, Thunderbird, KHTML, and its massively influential descendant WebKit, Safari, older Chrome, many others, and Blink, current Chrome, Edge, Opera, Brave, Vivaldi.
Gecko, WebKit, Blank, those are the big ones today.
Mostly, yes. It also lists some web-based engines, like a browser running inside another browser, interesting concept, mentions VR browsers and frameworks, like A-Frame we discussed, plus Argon or Toolkit, etc., a huge list of voice browsers or screen reader plugin software, JAWS, VoiceOver, NVDA, TalkBack, etc., some text graphical hybrids, old DOS browsers, Arachne, Amigos browsers, Plan 9, BIOS, even mentions an OS where the browser is the GIA, Spirit OS, and Gazelle, a research browser engine from Microsoft. It really shows the sheer variety of ways people have accessed and rendered web content over the years.
An incredible diversity of engines. Now, going back to styling with CSS units, we need ways to specify size. What are the key CSS units?
CSS offers two main categories, relative and absolute units. Relative units are defined in relation to something else. The most common is px pixels. While seemingly absolute, it's technically relative to the viewing device resolution. Is relative to the font size of the current element, or its parent if not set. So 210 means twice the current font size. X is relative to the x height, the height of the lowercase x of the current font. There are others like %rem relative to root element font size, VW, viewport width, VH, viewport height.
PXE, REM, viewport units, those seem most common for responsive design. What about absolute units?
Absolute units are fixed physical measurements, primarily intended for print media, but they work on screen too, though pixel density can make them look different sizes on different screens. They include PT points, traditionally 172nd of an inch, PC, picas, 1 picas, 12 points, millimeter, centimeters, and then inches. You generally use relative units for screen layout and absolute units maybe for print style sheets or if you need a fixed physical size for some reason.
Good distinction. Relative for flexibility on screen, absolute for fixed physical size. The doc also discussed pixel resolution and terms like DPI, PPI, DPPX. You mentioned ambiguity.
Yeah, people often use these terms loosely or interchangeably, but they have specific meanings, especially in web development now. The document clarifies DPI, dots per inch, is really about printer resolution, how many physical dots of ink a printer lays down per inch.
DPI for print.
Right. PPI, pixels per inch, describes the screen's pixel density, how many physical pixels are packed into 1 inch of the display. A retina display has a high PPI.
PPI for screen density.
Correct. Now, the crucial one for modern web CSS is DKPX, dots per pixel unit, or shorthand X. This represents the ratio of device pixels to CSS pixels. On a standard display, 1 CSS pixel usually maps to 1 device pixel, 1 DPPX or 1X. On a high-resolution retina display, 1 CSS pixel might map to 2 by 2 device pixels, 2 DPPX or 2X, or even more. This unit is used in media queries and the strict set attribute for images to serve higher resolution assets to high-density screens.
DPPX, or X, connects the abstract CSS pixel to the physical screen pixels. Very important for sharp images on fancy screens. Okay? The document also introduces W3.CSS. What is that? Is it like Bootstrap or Tailwind?
It's in that category, yes. W3.CSS, version 1.85 referenced, is a CSS framework developed by W3 Schools. Not the W3C itself, important distinction. It's described as being based on normalized.css, which provides consistent baseline styling across browsers. Like other frameworks, Bootstrap, Foundation, Tailwind, etc., its purpose is to provide developers with a ready-made, standardized set of CSS classes and rules for common styling tasks.
What kind of tasks?
Things like basic resets, typography, headings, paragraphs, styling tables, common UI components, buttons, cards, navigation bars, responsive grid layouts, color themes, containers, alerts, progress bars. The usual stuff you need to build a web interface. The idea is to speed up development and ensure a consistent look and feel without having to write all the basic CSS from scratch. The document doesn't list all the code, but mentions it covers a wide range of styling needs.
A toolkit for faster styling. Got it. Now, when a browser receives a file from a server, how does it know what kind of file it is? Is it HTML, an image, a video? That's MIME types, right?
Exactly. Multipurpose Internet Mail Extensions, or MIE types, are the standard way this is handled. They were originally developed, as the name suggests, for defining the format of email attachments beyond plain text, but their use expanded to the web via the HTTP protocol.
How do they work?
When a web server sends a file to a browser, it includes a content type header in the response, and the value of this header is the MIE type of the file being sent. A memo type is a main type and a subtype separated by a slash. For example, text TML, image PEG, image pegging, images VG plus XML, application PDF, application JSON, text race, text JavaScript.
Type subtype.
Right.
Tells the browser how to interpret the data.
Precisely. The browser uses the MIME type to decide whether to render the content directly, like HTML, images, pass it to a plugin, less common now, or offer to download it. The document provides a massive list of diverse MIE-type examples, really showing the specificity like application ATOM plus XML for ATOM feeds, various application VN types for vendor-specific formats like Microsoft Office documents or specialized scientific data. It highlights how crucial these identifiers are for the web to handle the sheer variety of digital content correctly.
A standardized labeling system for web content. Essential. Okay, the document wraps up with a glossary of key internet terms. Any crucial ones we should quickly recap?
It covered the fundamentals well, defining the World Wide Web itself, hypermedia, the internet, cyberspace, information highway, clarifying web server versus web client, basic actions.email, upload, download, surf, key technologies, hypertext markup language, HTML, web page, website, homepage, splash page, the browser's role, including the layout engine, addressing systems, IP addressing, domain name, top-level domain like .com, .org, .net, and the domain name system DNS, and domain name servers that translate names to IPs, and common acronyms, HTML, IP, DNS, TLD, URL, Uniform Resource Locator, the web address, PDPETSCA, different types of web apps, TCP/IP, LAN, ISP, just a good refresher on the core vocabulary.
Solid foundation. Looking ahead, the document briefly mentions metadata style sheets. What's that about? Sounds like CSS for metadata.
Kind of, yeah. It's presented as an idea or an existing option for managing metadata, dated about data like author, keywords, description, publication date, more efficiently than embedding it directly in every single HTML document, especially for large sites.
How would it work?
The idea is to store the metadata for multiple documents, maybe a whole site section, in a single separate file, likely an XML file. This central metadata file could then be linked to from the HTML documents, perhaps via a JavaScript link in the head that loads and potentially uses the metadata. The document also suggests maybe providing a direct link or a pop-up for users to view this metadata explicitly.
Centralizing metadata management could be useful for large sites.
Potentially, yes.
Yeah.
Could streamline updates if metadata changes frequently, rather than editing dozens or hundreds of HTML files?
Interesting concept. Finally, the document includes examples of a registration card and a survey. Why are these included here at the end of a deep dive into HTML and web tech?
I think they serve as a very practical, real-world grounding point, connecting all this technology back to the users and the creators. The registration card is the way creators gather basic contact info and maybe initial impressions. The SRVY goes much deeper, asking users directly about their experience with the content. Was it accurate, reliable, biased, unique? Were sources cited? Was it worth the price? What format do they prefer? Digital, paper.
Closing the loop with user feedback.
Exactly. It's a tangible reminder that all this technology, HTML, CSS, JavaScript, servers, browsers, exists to deliver content and experiences to people. And understanding how those people perceive and value that content through mechanisms like surveys is absolutely crucial for creators to improve and adapt in this constantly evolving digital world.
Yeah.
It ties the technical aspects back to the human element.
A perfect way to wrap up, emphasizing that user experience and feedback drive the whole process. Well, that was a truly fascinating deep dive into the history, evolution, and surrounding technologies of HTML. From its conceptual beginnings at CERN to the complex, powerful language underpinning the modern web.
It really has been quite a journey to trace. Tim Berners-Lee's initial vision for linked hypermedia, the early divergence and standardization efforts, the game-changing impact of HTML5 and features like Canvas, the essential partnership with CSS and JavaScript, and the ongoing challenges developers face with compatibility, performance, security, and just delivering effective content.
Absolutely. We've covered a lot of ground. And now for that final thought for you to ponder. Considering this incredible evolution of web technologies we've just unpacked, and that constant tension we see between open standards, proprietary solutions, and the sheer pace of innovation, what future developments do you think will have the most significant impact on how we create, share, and fundamentally experience information online in the coming years?
That's a big question. Maybe something around AI integration, or perhaps truly immersive web experiences beyond current VRR.
Definitely something to mull over as the web inevitably continues its relentless evolution.